Yeah, so welcome again. And worked on a very exciting, it's more than a project, it's a very established company by now. And they work with data visualization, what you can do with data. And I think it's a groundbreaking way of how they look at data. And
technology was actually so no one can do anything, right? Cool. Okay, and then mostly do it. Okay, I'm Michael. I work with Neo4j, which is actually not a graph visualization tool, but it's a graph database. So it's a database for storing connected information. So whenever you look in the real world, right, like we are, and you all know it actually, information is always connected. There's no piece of individual information that's disconnected from anything else. It's people, it's events, it's locations, it's products, it's, as we said, so consumption, it's meters, it's devices. Even if you look at like history or politics, all this stuff is connected from the past to the present. In sciences, you have stuff like proteins in biology, processes in chemistry or physics, where lots of factors influence the process. So everything that we deal with actually in our real world is connected, so there's no kind of isolation. So I'll skip over that because you can't read it. The idea is, okay, all this cool information is connected, really great. So actually now we want to put it in our IT systems, right, in our software somehow, right? So usually we want to store it somewhere in a database. Problem is most databases are not built for relationships, not built for connections. So when you put stuff in a database, usually it's either tables or something like aggregate things like documents or something, right? But the connections between these elements are really, yeah, it's kind of like step children in the database, right? No one really likes them, no one wants them, and if any of you ever wrote a program with a relational database that had like lots of joins, lots of connections built up in the query, then it took like forever to resolve that. Because actually most databases solve connections at query time. So when you ask for the data, so they look, okay, I have a piece of information here, I have a piece of information here. Who in the 5 million entries in these two tables could actually match between A and B, right? So and it takes a long time, costs a lot of memory and CPU. So Neo4j came actually exactly from the same problem. So there are people in Sweden, in nice Sweden, that built a system which was managing assets. So these assets were actually had two big problems. One was resolving permission, so who is allowed to access something, and who is not just a single person or a single company, but they were a software as a solution, software as a service company. So they had like 10,000 customers, all with kind of gigantic infrastructure, so groups and permissions and all this other stuff. And it was a pain to resolve. The other thing was natural language search, so they had tagged their assets in all the 27 European languages, and of course they wanted to search something in German, it was tagged in Swedish or in Russian, and even across synonyms and stuff like that, and they had the same problem. So it blew up, it didn't work, and long story short, they built their own solution for that, which evolved into becoming Neo4j. So they came from solving the same pains. And the trick that the graph database like Neo4j uses is actually materializing connections. Right? So if I, for instance, know clouds, then there's this kind of record stored in the database that captures this information. And this record is not put somewhere, but it's really kind of related to myself. So I have records of all the connections that I have. So whenever one wants to ask for something, what is might be connected to in whatever regard, be working somewhere, be liking something, being connected to someone, having read something, having bought something, whatever. There are kind of lists of all these connections directly stored with me. Whenever I ask for something, I directly get this information back. So it's a really high performance thing. So it doesn't cost you anything to store connections in these things. And that's really cool because what you can do now is kind of model the data and kind of whatever you want to do it like you would do it in the real world. So you just take your whiteboard and start to draw circles for you know, like this is Michael, this is Klaus, and I know Klaus. I'm at Agora now. Agora is in Berlin, right? And so on. whiteboard. So we can just model like we would do it with a whiteboard anyway, right? So and the cool thing about this is, of course, everyone understands this kind of, we draw information on a whiteboard. And when you look at the data coming out of a graph database, it looks the same way. So it doesn't look like tables, but it looks like the information that you put in, like nodes and connections or relationships. So, and the other cool thing that you can do is actually, you can ask the database in the same shape. So because what we wanted to have is not kind of having a nice database which is fast and can store this kind of connected information really well, but then you have to write really awful kind of queries to get the data out. Like I have to write 35 joins to get my data out of the database. So what we did actually, we looked at what people were using to represent this kind of shapes in emails. So when you write an email and you want to write, and you don't want to draw, just want to write, this is about Michael knowing Klaus, right? So what people actually do is they do open parentheses, and then just something like this and this, right? So dash dash greater than, or dash dash less than, and another word in parentheses, which is actually the same as this, right? And then you also say Michael, something like this, is at Agora, put parentheses around it, and you see that it's actually exactly the same information as in the picture. So what we did is we built actually a query language that uses exactly this kind of ASCII art to say so, to write your questions, your queries. And with that in kind of at hand, you can do actually whatever you want to. Right? So you can grab data from anywhere, you can grab data from public APIs, from Wikipedia, from the existing system, from whatever, put it into the database, and then start writing applications against it in any kind of query language, and any kind of programming language. And the thing why you have invited me is then you can use this information, of course, to visualize your information again. Right? Because you can say, okay, let's start with this person, for this kind of context, for instance, for her engagement in this kind of discussions, let's see whom else she's connected with, and then let's go a second step out, or third step out. Who are the other people in this area? What have they been working on? What are kind of the hot topics? What else is connected to this? So I can either kind of start to gradually explore this, but I can also say I want to formulate what I want to know in this kind of syntax, kind of ASCII art syntax, and then I send a query to the database, and the database returns me all the information. And then what you can also do is actually to use kind of the structural information that you have in the database. For instance, you know there's a person thing here. I can say, okay, that's a person. I can say this is, for instance, a place. This is also a person. This is a city. And so on. So you can use this structural information. So I have people knowing each other, I have people at places, I have people, places being part of cities. And use that for just having a visual search. So you don't actually have to write queries anymore, but you just use this information about the high-level information about the structure to build a visual search interface. And I actually wanted to show it to you, but I'm afraid I can't. Because it's, but we can look at the computer later. What I wanted to show you is actually, this is something which is not this. Let's see. So we can probably do it later on as a, there it is. But it's almost impossible to see, right? So, so what we have here is kind of nodes that represent the meta information in the database, in the graph. So we have here something like, I think this is a restaurant, or these are restaurants, and these restaurants are different kind of categories. So for instance, which cuisines do they offer, where are they located, what kind of facilities do they have, do they offer like special options, what price ranges do they have, and so on. And each of these categories folds out again into a tree of options, right? So what you do, you just, by clicking in this visualization, you would say, okay, I want to have restaurants located in Neukölln that serve vegetarian food and have a price range of X. And it would use kind of this information to generate these kinds of queries in the background, and then filter down the list of restaurants to the ones that you're interested in, put them on the map, do whatever, right? So even without knowing technology, you can use it by just using the structural information to search this data. Something else that you can do, which is kind of similar, is also possible to see, is have like an intelligent search where you can say, okay, I search for something, and I say I want to search for people. So I would kind of get a list of people that I could find in the database, and then I select a person, and then looking at the person, I would know what kind of other connections do I have for this person in the database. So I would offer, as the next step, as a drill down, only these kinds of connections that I could look for. For instance, I have a person, and then I want to, for instance, look at which articles this person wrote, right? And you go kind of down the road relationship, and then you can, as next steps, you have your articles, or the categories of articles. And you use this to really quickly narrow down a search result. So that's what's really cool. And the third way of searching more naturally on top of this data set, or on top of this database, is something like Facebook's graph search. They introduced it, I think, early last year, which is kind of a natural language approach to searching this kind of connected information. They say, show me all my friends that like red wine and live in New York and are free for tomorrow. And if you look at these kind of fractions or segments of these kind of sentences, then these are forming the same kind of patterns again, like my friends, so people that I'm friends with, that live in New York, is again a fragment like that like red wine is such a fragment, and you combine them to the same kind of query, write it against the database, and then you have your results as well. So you kind of take a small piece of technology that transforms kind of fragments of human language. English is especially easy to use there because it's such a simple language. And transform this automatically into a query against the database, and then you get the results, and you can then either list them or visualize them, put them on a map, or use them in whatever kind of way you want. And so this is kind of the capability to use kind of this kind of powerful, fast database in the background to store this connected information of any kind, but then allow people who are actually non-technical to access this information also really quickly and without restricting what they can actually do. Because otherwise, if you build a system on top of the database, then you automatically restrict what people can do, and you don't actually want that because you want to have kind of the free access to information in whatever way they want to go, in whatever way they want to look at it. And so that's pretty cool. And the last thing that I want to talk about is actually what's possible with that kind of database. Because in most systems you store just information of one area or one kind, right? So you have like a product system, you have like a discussion forum, you have like a movie database, stuff like that, right? It's always kind of centered around one thing. Because it's actually in many cases really hard to pull in lots of different domains into one database because they are kind of not well, because the database doesn't kind of support this kind of connection between things, it's really hard to bring them together. But in the graph database, actually, as connections are like data. So connection is not like something that I have to structurally create, but connections are like data. I just change my database, adding new connections on the fly, even new types of connections, as I would just change like a name attribute of a person or something like that. So you're not bound to kind of going to a technical person to allow you to add new types of connections to the database and new connections themselves, but you can do it whenever. So that means whenever I have multiple data sets from many different sources, I can bring them together by just finding one joint point where I can find them, where I can connect them. So for instance, a person or a place or an event or a piece of information that is kind of common to both data sets is enough to connect them, because then you can use this kind of connection between the database to query across the two data sets. So I can, for instance, bring like articles from energy research together with the kind of the financing information that banks have, like rating and risk management stuff. I can bring in at the same time kind of patents that are pending for certain things. I can put in discussions or kind of new interesting projects from Kickstarter or something like that. And I can just connect them by the even by keywords or something like that. And then I can kind of see the bigger picture, take a step back and see the bigger picture. Because now I have the ability to pull in all the different data sets into a holistic view and then kind of ask the questions that I want to ask you. And I think, as I can't show you any demo or any real world stuff on this light background, that's more or less it. Let me try if I have, so we added a dark theme to our UI lately. And let's see if the dark theme actually works here. Can you see something? So, let's see. Also something is happening here that my computer is really getting super sluggish. I'm not really sure. Okay, dark. So, come on. So it's very dark, right? As you can see. Just as a quick demo to show you what it could look like is, I have actually here a movie dataset. And when I add this dataset to my database, it's really hard. It's impossible to see. Right? So actually what you would see here, if I would show you my computer, if I show you my computer, you actually can see that it takes these movies and the actors in the movies and represents them as I drew there as bubbles and arrows. And in the arrows you have information about relationship. For instance, this is a directed relationship, this is an acted-in relationship. You can get more information out of the individual things. And then you can start to kind of query this graph. So for instance, I can say, give me all the movies of Tom Hanks and all the directors of the movies that he acted in, right? So I write a query, match person name is Tom Hanks, and give me all the movies he acted in and all the people that directed in them. Really almost like the English sentence. Send it to the database and I get this kind of information there. And you can then use either this information in another system or process it in your UI front end, or you just can visualize it like this so that people can then continue to work with it. For instance, here when I click on a director node, I see the other movies this person, for instance, produced, or for the Mahrowski, I see that the other Matrix movies, for instance, are in here in cloud class. Right? And then from the Matrix, I can continue to look and see, okay, these are all the actors, and so on, and these are the other movies they acted in, and so on. So I can also kind of just exploratively work through this data. And this is also a really nice approach that people just have like a hunch about something, and just by looking at the data and kind of connecting the dots, they actually can confirm their theory or disprove it. And that's also kind of an interesting way of working with this kind of connect. Yeah, so this is more or less it. So the demo I wanted to show actually is to see how you can actually pull in data from different data sources. So my example is a developer community being active on Twitter, on GitHub, on Stack Overflow, on Meetup.com, and all the different places. How you can actually see kind of who's active in general. So you want to see the whole picture, so you pull in the data from all the different data sources into one kind of consistent graph, and then you can start to create, see people that are active on Meetup.com. We also answer questions on Stack Overflow. People that tweet on Twitter a lot, are they actually contributing, or are they just noisy people that want to kind of get attention or something, right? And so you can kind of see also how your community developed. If people that started to be active at this point, are they still active now, or how did their activity change over time and stuff like that, across all the different channels. That's stuff that you could do as an example to how you would understand your community. And yeah, that's more or less.
I have a couple of questions, so just get one. Do you have any examples of implementation of this technology?
So Neo4j is a database that is exactly this. Okay. It's an implementation. So it's an open source.
What I meant was, if you have an example of implementation, like that you have a database that works in another system, and there's a query that happens a lot that takes, X CPU, and after you guys